light energy. Do you know what is the meaning of light energy? It is a form of energy. Already we know it has different types of energy. Yes, light energy, heat energy, sound energy, mechanical energy. Here we are going to study about light energy. In this light energy, it is a small topic is refraction. Okay, what is that? Refraction. How the light travels from one medium to another medium? Normally light travels in straight line. We all know that. But from one medium to another medium, when a ray of light travels from one medium to another medium, for example, air to water, from glass to air, from glass to water. When the ray of light travels from one medium to another medium, change its direction. Okay, when we look the object, it will be bends. For example, listen, one pencil is here in the water. Here the medium is air. The medium is air, here water. Air is the first medium, water is the second medium. When the ray of light travels from air to water, when we see the water in that object or in that light, the light will be change its direction. Okay, when we look the water, we can see the light from this place. But actually the light travels through the straight line. But in this, from one medium to another medium, when the light travels to move, it will be like bent from the normal ray of light. So it is called refraction. For example, a pencil immersed in a water, it appears to be bent. What is the reason? This is called refraction. Okay, this means when a ray of light travels from one medium, this is the air medium, this is the water medium. Okay, so the ray of light travels from one medium to another medium. It is a change in its direction. Okay, at the boundary of the between two objects or two medium. This is called refraction. Okay, when a ray of light travels from one medium to another medium, it has a change in its direction at the boundary between the two medium, from air to glass. This is called refraction. Light travels with different mediums in different speed. Okay, light travels with different speed in different mediums. For example, air, water and glass. Okay, the speed of light in air is 3 into 10 power 8 meter per second. Okay, what is the speed of light in air? 3 into 10 power 8 meter per second. Okay, according to the medium, it will change. The speed of light will be changed. Okay, the speed of light will be changed according to their speed of medium or different medium. Okay, if in any other mediums, which will be the value of the speed of light will be less, means it's going down, means it is optically denser. It means according to their medium, it has classified into two types: optically denser and optically rarer. Okay, optically rarer and optically denser in a medium. Okay, the speed of light goes down. Okay, the speed of light slows down, means it is optically denser. Okay, so these are the optically denser. When we compare the speed of light in air, the denser in the glass. Okay, so the value of the speed of light in water is 2.25 into 10 power 8 meter per second. In glass, 1.8 into 10 power 8 meter per second. Okay. These are the different mediums in the speed of light. Okay. The speed of light in different mediums. In air 3 into 10 power 8 meter per second. In water 2.25 into 10 power 8 meter per second. In glass 1.8 into 10 power 8. From here we will know how the densities, otherwise how the speed of light will be changed according to their optically rarer or optically denser. Okay. Here the value is more, but it has the, when the value is less, it has the optically denser. So from here we will know that water is optically denser than air. Okay, because this is the value is less. Okay, value is less in water. So the water is optically denser than air. Then it is the glass. Yes, glass is optically denser than air and water. Okay, it is the value is very less. So glass is optically denser than air and water. Okay, from here we will say optically rarer. How it will be? Water is optically rarer than glass. Okay, water is optically rarer than glass. Then air is optically rarer than water and glass. Okay, because this is the highest value. Okay, the value is highest in the medium. It is the rarer, optically rarer. The values are lowest in the medium. It is the optically denser. Okay, so water is optically rarer than glass. Air is optically rarer than glass and water. Next one is principle of least time. Principle of least time. In all the possible paths, the rays will be travels from one medium to another medium. For example, from air to water, from air to glass, from water to glass, glass to water. Okay. So it has more possible paths. Light travels from one medium to another medium. For example, this is the one object. This is another one object. This is one medium. This is another one medium. Okay. Light travels in different paths. It will be go like this. Like this. Okay. So it will take more possible paths. Okay. The light travels from one medium to another medium. It takes the shortest time. The speed of light in different mediums, it will be changed. Okay. So in which time it will be take shortest to move the light from one medium to another medium? It is called least time.
Now we can see some common examples of refraction. A fruit appears to be bigger in size in a glass of water due to refraction. It means water is more optically dense than air, so light would bend towards the normal. Due to this, different light rays meet above the actual position of the fruit. This refraction causes the bending of rays and results in the diverging image. Therefore, the fruit appears to be raised and slightly bigger. Printed text appears to be raised when seen through a glass block placed over it. The letters appear raised because of a refraction. Where light travels from one medium to another, it bends. It means either towards or away from the normal. This happens because different medium have different densities and thus the speed of light is different in each one of them. An object seen in the water will usually appear to be at a different depth than it actually is due to the refraction of light rays as they travel from the water into the air. A person's leg also appears shorter than the actual length when the person is standing inside a pool.
Here, a ray of light traveling from one medium to another medium. For example, from air to glass. Okay, this is the medium of air, this is the medium of glass. Okay, from one medium to another. Ray of light traveling from one medium to another medium. When the refraction of light, it has different terms. Okay, terms related to refraction. It has different terms. The ray of light will be refraction. First one is incident ray, refracted ray, point of incidence, normal, angle of incidence, angle of refraction. These are the terms related to refraction. Okay, what are they? Incident ray, refracted ray, point of incidence, normal, angle of incidence, and angle of refraction. Okay, listen here. A ray of light in the first medium. Okay, what is this? Incident ray. A ray of light in the first medium. First medium is here, second medium is glass. So the ray of light in the first medium is called incident ray. So what is the ray of light here? AO. Okay, so AO is the incident ray. Okay. AO is the incident ray. Next one is refracted ray. Okay, the ray of light. This is the ray of light. The ray of light after changing its direction. Listen, the incident ray after bounces the glass. It is the second medium. After bounces the glass, it will be changed the direction of the ray of light. Okay, the ray of light after changing its direction in the second medium, it is the glass. Okay, so the ray of light after changing in the second medium, changing its direction in the second medium is called refracted ray. So OB is the refracted ray. OB is the refracted ray. Next one is point of incidence. Okay, point of incidence means it is O. The incident ray at the point of interface at the point. Okay, the point where the incident ray interface at the point of incidence, in the middle point of the incidence. Okay, it is called point of incidence. So O is the point of incidence. Okay, the point where the incident ray interface to the medium. Okay, it is called point of incidence O. Next one is normal. Okay, what is the normal? It is a perpendicular line drawn to the air to glass at the point of incidence. Okay, to the two mediums. Okay, the perpendicular line drawn to the air to glass at the point of incidence is called normal. So here G to H. Okay, GH is the normal. It is the perpendicular line. Next one is angle of incidence. Okay, the angle between the incident ray and normal. The angle between the incident ray and the normal is called angle of incidence. Here angle I. Mention the angle of incidence is I. Okay. When we say the angle AOG. Okay. Angle AOG is the angle of incidence, or angle I is the angle of incidence. So angle between the incident ray and normal is called angle of incidence. Next one is angle of refraction. Listen. The angle between the refracted ray and the normal. Okay. The angle between the refracted ray and the normal is called angle of refraction. That is R. Here BOH. BOH is the angle of incidence. Okay, do you understand this? These are the terms related to refraction. Here AO is the incident ray, OB is the refracted ray. Okay, O is the point of incidence in the medium. O is the point of incidence in the medium. Next, GH is the normal. GH is the normal ray of incidence. Next, here angle I or AOH is the angle of incidence. AOG or angle I is the angle of incidence. Next, BOH or angle R is the angle of refraction. BOH or angle R is the angle of refraction. The line AC, after touching the second medium, the refracted ray bends towards to the normal. Okay, because air is the rarer medium, glass is the denser medium. So when the incident ray after touching the second medium, the refracted ray bends towards the normal. Okay, from here we can know some rules of refraction. Okay, first rule is, listen, when a ray of light from the rarer medium to the denser medium, it bends towards the normal. Okay, this perpendicular line is the normal line. So the incident ray of light from the rarer medium, it means air, from the rarer medium to the denser medium, the refracted ray bends towards the normal. So the angle of refraction or less than angle of incidence. Okay, angle of refraction or less than angle of incidence. Okay, next one is in the second picture, second rule, from the denser medium. Okay, the ray of light from the first medium, it is the glass, from the denser medium to the rarer medium, here it falls on the refracted in the second medium, but the ray of light, it bends far away from the normal. Okay, the ray of light touches to the second medium. The ray of light from the denser medium to rarer medium, the ray of light bends far away from the normal. Here it is the short distance. Here the angle of refraction is more. Okay, so the ray of light or refracted ray bends far away from the normal. Here angle of R or angle of refraction greater than angle of incidence. Angle of refraction greater than angle of incidence. Okay, the denser medium is glass, rarer medium is air. Okay, did you understand the picture here? Refracted ray bends towards the normal. Here refracted ray bends far away from the normal. Okay, from this picture, the ray of light from the rarer medium to denser medium, it falls on the perpendicular surface of the medium. Okay, it will be not create any angle of incidence. The light ray falls on the medium in the separation, that means perpendicular surfaces. So it has no deviation. Okay, it cannot make any angle. So the angle of incidence is equal to angle of refraction. It means 0 degree. Okay, angle of incidence is equal to angle of refraction is equal to 0 degree. It will not make any deviation. It will be not create a deviation. So it has no angle, 0 degree. According to the principle of reversibility, the path of light is reversible. Okay, the light passing through from one medium to another medium. Again, the light pass from second medium to first medium. Okay, here the path of light is reversible. It means the path of light from air to glass is A to O and O to B. A to O to B. Okay, the path of light rays from glass to air means B to O and O to A. Okay, so in each medium can reversible the ray of light from one medium to another medium. From here we can know two laws of refraction. Okay, two laws of refraction. What is the first one? The incident ray, the refracted ray and the normal point of incidence all lie in the same plane. That means the incident ray, the refracted ray and the normal point of incidence all lie in the same plane. Okay, this is the same place. So this is the first law of refraction. What is the second law of refraction? It means refractive index, the ratio of sine of angle of incidence to the sine of angle of refraction. It means n is the refractive index. N is equal to sine I divided by sine R. This is the second law of refraction. It means the ratio of sine of angle of incidence to the sine of angle of refraction is constant. Okay, what is the second law of refraction? The ratio of sine of angle of incidence to the sine of angle of refraction is constant. It is called refractive index. So n is mentioned as refractive index. Okay, in the higher class we will study this formula in the Snell's law. Okay, what is the name of this law? Snell's law. Okay, when we have to find the refractive index, we have to know another one formula. Okay, the ratio of the speed of light, the ratio of speed of light in air to the speed of light in another medium. Okay, to find the refractive index we should use this formula, the ratio of speed of light in air to the speed of light in another medium. It means glass, water, always the air, the speed of light in air is same, it will be not changed. This is a formula. Okay, the speed of light in air, speed of light in another medium. It means glass, water, diamond, any material. Okay, so to find the refractive index we have to use this formula, the ratio of speed of light in air to the speed of light in another medium. Listen the first question. The speed of light in air is 3 into 10 power 8 meter per second and the speed of light in glass is 2 into 10 power 8 meter per second. What is the refractive index of glass? Listen. Solution. What is the formula to find refractive index? Refractive index is equal to speed of light in air divided by speed of light in another medium. Yes. So refractive index is equal to speed of light in air divided by Then another one medium is speed of light in glass. So we can write here speed of light in glass. Speed of light in glass. You should mention the formula. Okay, before doing the problem, you should mention the formula. Then speed of light in air. What is the value? 3 into 10 power 8 divided by speed of light in glass 2 into 10 power 8. Okay. We have to cut here. Then 1 2 is 2 here. 1 2 is 2. 1 balance. Yes. So 1, when we have to add 1 0, we can divide here 3 2. 1 2 is 2. 1 balance. We have to add 0 here. Decimal. Okay. So again 5 2s are 10. Okay. So answer is 1.5. 1.5. Don't write unit. Okay. Refractive index has no unit. So no need to write the unit here. Okay. Just we have to divide these numbers and write the answer. No need to write the unit in refractive index. Listen here. If the speed of light in air is 3 into 10 power 8 meter per second and the refractive index of water is 1.33. Find the speed of light in water. Okay. Solution. First we have to write the formula. Refractive index. Refractive index is equal to speed of light in air divided by speed of light. Listen. Find the speed of light in water. So another medium is water. Speed of light in water. Listen here. In the question we have given refractive index of water is 1.3. So refractive index equal to 1.33 is equal to speed of light in air. Already we know what is that? 3 into, it will be not change. Okay, 3 into 10 power 8 meter per second divided by speed of light in water. We should find it. Okay, so now we have to take speed of light in water in x. Okay, this we have to find it. So we have to take x. Then x equal to 3 into 10 power 8 divided by refractive index will be going to division 1.33. Okay, so here we cannot divide these numbers. Here decimal number. So we should change the number. 3 into, we have to multiply with 100. Okay, 3 into 100. Here 1.33 into 100 into 10 power 8. Okay. Then 3 into 100, 300 divided by 133. When we have to multiply with 100, it will be remove the decimal. So 133 into 10 power 8. Now we should divide the numbers. 300, 133. Listen here. 1 into 133 is equal to 133. So we have to divide 2. 2 3s are 6. Again 2 3s are 6. 2 1 is 2. Subtract the numbers. 10 minus 6 equal to 4. Here 9. 9 minus 6, 3. We should add 0 here. Okay. Only 2 digits are there. Again we have to keep on decimal here. Then what we have to do? Again we have to multiply with 2. 2 3s are 6. 2 3s are 6. 2 1 is 2. Subtract the numbers. 10 minus 6, 4. Here 3 will be here. Okay, so 13. Here 2, here 10. 13 minus 6, 7. Again we have to add 0. Here multiply with 5. Okay, 3 5s are 15. 1 balance. 3 5s are 15. Plus 1, 16. 1 balance. 1 5 is 5. Plus 1, 6. 10 minus 5, 5. Here 3. 13. 13 minus 6, 7. It will be go. Okay. So, answer is 2.26. 2.25 into 10 power 8. Here we have to write 10 power 8. Okay, children? Then we have to add meter per second. Because here we have to write the second unit, speed of light. Okay? Only the refractive index, we will not mention the unit. Speed of light in air, speed of light in water, we can write the units. Have you understand this? Children, you have few homework from the book, page number 86, exercise homework. Okay, page number 86, 7, 8, 9 and 10. 4 questions are there. You should try it. Okay. In all the questions, we have to write speed of light in air is 3 into 10 power 8 meter per second. Okay. Few questions they will be asked. Refractive index. After writing the refractive index, no need to write the unit. Okay. Then another few questions you should find it. Speed of light in another medium. Glass, diamond or water, anything. Okay. There you have to write the unit. Okay. It is easy. You should do like homework. Okay. And also you should refer the book which we learned today. Thank you.